Hello everyone, I am Ashwara. Today we are discussing about class 11 physics chapter number 4 motion in a plane. In this lecture we will discussing about that the accelerations. Okay, in the last lecture we will discussing about that the velocity. In this lecture we will discussing about that the acceleration. Now first of all, what is acceleration? We have already known about that the accelerations. What is that the there are the two positive acceleration, negative acceleration, and zero accelerations are there. So the we have already known in the motion in a straight line. Also, what is acceleration? Its unit, how it derive, at its intensity as well. Accelerations are there. So we have already known about that, but now we are discussing about in motion in a plane. On that time, what is the accelerations and how it works, and also so in this lecture we'll discussing about that. Now see here the acceleration, average accelerations of an object for and a time interval delta t moving in an xy plane is the change in velocity divided by the time interval. So delta v by delta t average acceleration is that del a bar it is equals to delta v by delta t. It is equals to delta it is equals to delta v where v it is equals to vx I cap plus vy j cap it is equal so divided by the delta t. So it is equals to delta vx I cap plus delta vx I cap upon delta t plus delta vy j cap divided by delta t. So Vx upon delta Vx upon delta t it is equals to Ax I cap plus Ay j cap. See here in terms of x and y, Ax and Ay can be expressed as also we will know about that the derivation two times derivation of the displacement vectors. So d square x by d1 dt dx upon dt, so it is equals to known as the d square x upon dt square, and also ay it is equals to d by dt, dy upon dt it is equals to d square y by dt square. So see here accelerations. See here there are the v y j cap vx I cap. See this is the velocity of these vectors and this is represented the vx I cap plus vy j cap. The component of vx and vy velocity v and the angle theta it makes with the x axis, not that the vx it is equals to v cos theta and vy sin theta. The accelerations of is limiting value the average accelerations as the time interval approaches 0. So it is equals to limit delta t tends to 0, it is equals to delta v by delta t. So since delta v it is equals to delta vx I cap plus delta vy j cap, it is we have limit is that we have, so I it is equals to I limit delta t tends to 0. So delta v by delta t x plus j limit delta t tends to 0. So delta v by delta t, but it is equals to delta ax I cap plus ay j cap, it is equals to also known as that the ax if we are taking that the limit at here delta t tends to 0. So on that time it is why this value is where becomes to near equals to 0. So we will get that the no we have not taking the 0 but we have taking that the nearly equals to 0. So ax it is equals to dbx upon dt, ay it is equals to dvy upon dt. So as in this equation, this case of velocity, we can understand the graphically the limiting process used in the definite accessions on a graph showing in the path of the object motion. So this is shown in figure. Okay. So to represent the positions of an object at time t, p1, p2 and p3, positions after, see here, positions after that v, p1, p2, p3 are there. So positions after delta T1, delta T2 and delta T3 respectively, then the what is that, the P, P1, P2 and P3 are also shown in figure, okay, ABC. So in case of delta T, delta V is obtained using the triangles law of vector addition. By definition, the directions of average acceleration is same as that the value of delta V. We see that the delta T decrease, the directions of velocity will be changed, and the consequently the directions of the accelerations change. Finally, in the limit delta t tends to 0, the average acceleration become as instantaneous acceleration and has the direction is shown in figure. Here this is our examples are there, P1, P2 and P3 are there. So there are the time delta V, here change the delta V, positions of P at positions in this direction, in this directions, in this directions and also in this directions are there. So it is changed with the point time delta T1, delta T2 and delta T3 respectively. So it is P1, P2 and directions of A bar, P1, P2 and P3. So directions of A in these directions are there. So it is making a V dash open V, it is equals to delta V. Here also V dash to V. It is delta V, also V dash upon V is equals to making a delta V. But see here, where V and A is perpendicular to the tail of these vectors. So note that in one directions the velocity and acceleration of object are slowly along the same straight line directions or in the opposite directions. However, either in the same direction or in the opposite directions. However, the motion in two or three dimensional velocity and acceleration vector may have any angle between 0 and 180 between them. Now see here, due to this slides, what is the accelerations? See here, the particles move along the curve path as shown in figure at time t1. Its positions is r0 and its time t2 at its positions rf. See here, and ri when the time is t1 and rf at t2 is the position is rf. So what is that? See here, the velocity is that velocity is Vi and also Vf are there. So now see here, what is that? See, it is going to this head and tail velocities are there. They have combined to each other. On that time, what we will get? There are the delta. We are getting that the value of delta V. So average positions, average accelerations are the delta V by delta T position in a directions of delta V. So see here, again I shows you what is that. Now our accelerations are there. What is that? R at T1 is the its positions is Ri. Here these are one mistakes are there. Ri, okay. It is not R0, it is Ri. On that time it has a velocity Vi in these directions, and one whenever it is its time T2 its positions is Rf. On that time it is Rf. So the positions is that Rf. So what will happen when the positions it has a velocity is Vf. So see here there the velocity is that. So now it is we have addition of this both the V and Vf like that. So we will get that the value of delta V it is equals to AV delta V by delta T, the positions in the directions of delta V. So see here a non-zero acceleration change in as an object State of motions, average accelerations ev it is equals to delta v by delta t. Now instantaneous acceleration a it is equals to limit delta t tends to 0 delta v by delta t. Okay, delta v by delta t. And this our interpretation similar to delta a v average and the v. Okay, so this is our accelerations. So motion in a plane with the constant accelerations projectile. And after we will discussing about that, the once it leaves the on. So guys, this is our accelerations are there, and also we know about that accelerations. So this phenomena is that. Now if you have any kind of problem, any kind of doubt in these lectures, then comment in the comment box. Thank you guys, thank you so much.